So this isn't about the teeth?
No, we're out of the teeth now. Okay, so now we're continuing digestion. We're headed down the gullet. Let's talk about what has just happened. So after mechanical processing by the teeth, what am I talking about? Mechanical processing here is what? Chewing. There's a word for that. Try not to giggle. It is. The word is mastication. All right. That is the actual word for chewing, which is why the muscles inside the jaw are called masseters, or some of them. You have other ones, temporalis, and so on and so forth. After mechanical processing by the teeth and initial chemical processing, by the what? Not yet.
Saliva.
There we go. By the saliva. Food is swallowed. Okay? Now, I want to focus on that guy for just a moment. Let's take 2 arrows over. One is how much. I asked this earlier today, and people gave me enormous numbers and made the real numbers seem so low when they really are like 15 gallons. That's a lot of saliva. No. It's between 1 and 1.5 liters per day. That's it. 1 to 1.5 liters per day. Much less than when we sleep than when we're awake. But yeah.
Quite a bit though. It's like a soda bottle.
That's
How much does
yeah.
it increase when you chew gum?
You know, that's a fantastic
I chew
question.
gum every single day.
I would imagine that you'd probably be closer to this number than this number because your brain is thinking, what is this that we can't digest? What are we fighting here? You know, usually we chew something up, maybe 30 at the most if it's meat, and then we swallow that thing. So yeah, I imagine we produce a lot then. I know guys that wrestled in high school, they would spit in a bottle a lot if they were trying to cut weight and chew gum and stuff. Not a great plan, but better than running with trash bags or using laxatives or various other dumb things that my friends did. All right. What is it? It is a mixture. Technically, more than a mixture, it's a solution of water. Water makes up 99.5% of this. And I think, why does the and matter? 99.5%, that's most of it. Shouldn't that be enough? Well, let's look at it from this perspective. If I pour you a glass of water and I pour you a glass of saliva, which one are you going to drink?
Water.
But this one's 99.5%. It's that 0.5 we'd be concerned with. It's got the little bubbles in it. You're like, hey, something's weird there. Okay? Let's talk about that. What else is in saliva? It's true, but not because we make it. I agree. Enzymes would be in there. We don't want a whole lot of acids or bases in this because of the teeth. Acids would be really bad. When we get to the stomach, we'll have a bunch of those. Enzymes. And I'm going to give you just one example. There's one called Salivary, and I'm going to say it like it's spelled, amylase. It's actually pronounced amylase, and its job is to break down carbohydrates. Its job is to break down carbohydrates. Now, there's other enzymes in saliva, but that's the primary one. That's the one that gets the most attention. In addition to this, there are something called glycoproteins. Glycoproteins are important because they make the food slick. They lubricate food so that it can pass much more easily down the esophagus. So the glycoproteins are really important for that. And basically, they're a combination of a protein molecule with some sort of carbohydrate molecule. In addition to that, there's a few other things, but electrolytes. Like sodium, potassium. Not too much sodium because your saliva is not particularly salty. And then also Ca2+, calcium.
Hey, Hallie, what is good?
Oh, I'm on the line. Yeah, here you go. So Na+, K+, Ca2+. Those are all electrolytes. And so this is these are the primary components of that 0.5 that make up saliva. Once we've chewed stuff up, it's getting ready to get passed down. It doesn't use gravity. As I illustrated by standing on my head the other day, gravity is not necessary for us to swallow stuff. Now, swallowing is a coordinated...
You screwed it up, Mr.
I
Hallie.
did it again. Look at that. Coordinated effort of many muscles organized and controlled by the medulla oblongata, portion of the brain stem there. This guy, the lump right below the pons in the brain stem. Is swallowing voluntary? Sort of. The initiating of swallowing is voluntary, but the action of it is facilitated by the medulla. So we start the process, but all these muscles squeezing together in the proper sequence is something that's initiated by the medulla to raise the larynx up, to move the muscles of the throat, to coordinate all that. It takes a coordinated action, and the medulla does that. That's not the only one it does, because the medulla does things like sneezing also. Though you can trigger a sneeze by maybe sticking some pepper up your nose, you can't really make yourself sneeze. It's a coordinated group of muscles working together for an action. Also, like vomiting, you can trigger things to make yourself vomit, but you can't be like, I'm gonna throw up. Huh. It's gotta happen. Your stomach has to contract in a powerful contraction, and like everything gives way. Also, the medulla that's doing that, coordinating groups of muscles for a complicated action. And this one's pretty complicated because you got to make sure that you don't, suffocate, or you got to make sure you don't shove food down the wrong spot, and that the muscle action that pushes it continues all the way. So there's a lot of things involved. We do, however, initiate it. It is initiated by the tongue pushing food or liquid against the roof of the mouth. There are touch receptors, which are nerves. Oh, I'm on it again. Yep. Activate. Touch receptors or nerves will activate as a result. So on the roof of your mouth and your hard and soft palate, there are nerves in there that respond to touch from the food being pressed up against that, and the tongue being pressed up against that. That's also the purpose of the little hangy ball thing back there. The uvula has these touch receptors in there as well. It's not to say if someone has their uvula removed that they won't be able to swallow food anymore. That's not true. There's still enough of them in the soft and hard palate to be able to carry it out. This begins a process known as peristalsis. Peristalsis. Peristalsis, folks, is how food moves from one end to the other. From the moment it's swallowed to the time that it's pooped out, the way that it moves is peristalsis. It's peristalsis that actually moves poop from the rectum into the bowl below. Okay? It's waves of muscular contractions. Food, I'm going to write another word here. After food's the processing begun, it's called a bolus. Bolus. From one end to the other. Waves of muscular contractions. That's how stuff goes. It's not gravity. Okay? One of my students brought up an interesting thing today. He said, I read an article that said that astronauts have to be told when to pee. I said, what do you mean? He said, because their bladders won't know. And I thought that was weird because they have touch receptors that are different. Like in the bladder, there are stretch receptors or neurons that respond to being stretched. And I thought, why would it be? Because they wouldn't be stretched in the same way in a zero gravity situation because the liquid would just be floating inside of the bladder. So I'd never heard that. I do know that astronauts get kidney stones a lot more frequently than people on Earth because without gravity those crystals form a lot easier. I know that because the scientist I worked with when we went to NASA for our zero gravity flight, he was in charge of the study about astronauts and their kidney stones. He had them trying different medications to try to decrease the amount of kidney stones. All right. So food passes. Here, let me draw this first, just briefly. We're going to draw a tube with a dent in it like that, okay? That's food, or bolus. And what happens is the tube squeezes, okay? Kind of like, do you guys remember the Orange Bowl game we played at SFR?
Yeah.
Where you had to stick the pantyhose on your head with the orange in it and swing it around?
I had to do that.
To get the orange through the pantyhose would be something similar to what peristalsis is. If you had to stick it in there, then you kind of have to squeeze the pantyhose to push that orange to the very end to get it there. That's more or less what's happening to your food in these tubes. The tubes have to squeeze and they push the bolus along the track. That process is called peristalsis. Okay. All right, so food passes from the mouth to the pharynx, over the flap called the what? Epiglottis. Down the what? The esophagus. To the stomach. That is the pathway. Okay. Now, it travels through the thoracic cavity in this process, but it's sealed off. And the base or the bottom of the thoracic cavity is a dome-shaped muscle that allows you to breathe. What's that dome-shaped muscle? The diaphragm. There's only a few holes in the diaphragm. Otherwise, it wouldn't be able to function. One of them's for the aorta, one's for the inferior vena cava, and the other is for the esophagus. Okay. So you have hiccups, right? Which are spasms of the diaphragm. The way to kick the hiccups, if I've ever told you this or not, if you take a drink of liquid for 10 seconds while holding your breath, because you're forcing your diaphragm to stay stationary, and at the same time, you are causing these waves to go through it. I honestly believe it calms the diaphragm, because what hiccups are is a spasm of the diaphragm. And so those waves, that peristalsis going through, causes that passageway that goes through the diaphragm to kind of cause these waves to sort of calm it down from what it's doing. Physiologically, I have no idea why it works, but it does. Anyway, so let me show you a picture of this illustration really quickly, and then we'll call it a day today. We just needed to get into the stomach from where we were. Now we're here, we'll be able to be all right. See, here's our destination. It's kind of gross looking. That's a stomach. That one's pretty huge too. Chunk of liver cut out of that one. Here is a picture of peristalsis, kind of contraction of the muscles that push that from the mouth toward the anus. And here's a picture here. We're going tongue, pushing the food up here, passes down over the epiglottis, through the pharynx, down the esophagus, and then right here would be the diaphragm, and then into the stomach. That diaphragm separates the thoracic cavity from the abdominal cavity. So stomach's on your left side, and then your liver is on the right side. And that just about does it for today.